The topic is properties of inequalities. The essential question is, what are the effects of adding, subtracting, multiplying, or dividing a number on both sides of an inequality sign? Okay, so we're going to backtrack just a tiny bit. So I want you to remember that when you work with equations, now I know we're talking about inequalities, but we're flashbacking to equations. When you work with equations and you perform an operation such as adding, subtracting, multiplying, or dividing a number to both sides of the equal sign, the equation is going to stay balanced. It's going to stay equal on both sides. And here's what I mean by that. So if we had this equation right here, it's an equation because there's an equal sign. 4 plus 1, well, that equals 5. So this side is equal to this side. When you add the same number on both sides of the equal sign, look what happens. Let's just go ahead. I'm just going to add 6 to both sides. So I'm going to add 6 to this side, and I'm going to add 6 to this side. Well, 4 plus 1 is 5, plus 6, that's 11. And then isn't 5 plus 6 11? So when I added 6 to both sides of the equal sign, it's true. So 4 plus 1 does equal 5, so that was true. And then doesn't 11 equal 11? So that's still true, even after we've added the same number to both sides of that equation, that equal sign, okay? So let's see what happens when we subtract the same number on both sides of the equal sign. First, let's make sure this is true. 3 plus 4, that equals 7, so yeah, that's true. Okay, now instead of adding 6, let's subtract 6, because we're going to subtract the same number. So subtract 6 from over here, subtract 6 from over there. Well, 3 plus 4 is 7, 7 minus 6 is 1, and then 7 minus 6, that's 1, so doesn't 1 equal 1? Yeah, it's still true. That equation is still true, even after we've subtracted 6 from both sides. All right, let's see what happens when we multiply by the same positive number on both sides of the equal sign. So let's check and see if this is true. 2 is equal to, 1 plus 1. Yep, that's true. All right, so let's multiply by the same number on both sides. Let's multiply by 3, positive number. So times 3 here, and then times 3 over here. 3 times 2, that's 6. And then we got right here, 1 plus 1 is 2. 2 times 3 is 6. Yeah, doesn't 6 equal 6? Sorry, that should be in blue. Yeah, that's still true. All right. Now, what happens when we have an equation? We multiply by the same negative number on both sides of the equal sign. Let's check and make sure this is true. So we got, 5 plus 1, that's 6, and that equals 6. Yep, so both sides are true because they're balanced. It's a true statement. And so we're going to multiply by the same negative number on both sides. So instead of multiplying by positive 3 like we did up here, we're going to make it negative. Let's go times negative 3. We're going to times this by negative 3, okay? So 5 plus 1 is 6. 6 times a negative 3 is a negative 18. And then 6 times a negative 3, that's negative 18. So isn't 18, negative 18 equals a negative 18? Yep, still true, after we've multiplied by a negative 3 on both sides of that equal sign. Okay, now what happens when we divide by the same positive number on both sides of the equal sign? Let's go ahead and make sure this is true. 3 plus 5, yep, 3 plus 5 is equal to 8, so that's a true equation. And let's go ahead and divide both sides by 2. Okay, so 8 divided by 2, that's 4. And then 3 plus 5 is 8. 8 divided by 2 is 4. Doesn't 4 equal 4? So this is still true even after we've divided by the same positive number on both sides. All right, dividing by the same negative number on both sides. So let's go ahead and examine this equation. Is it true? 9 plus 1 is 10. 10 equals 10. So yeah, that's true. All right, we're going to divide by the same negative number. So let's divide this time by negative 2 on both sides. Okay, what do you think is going to happen in the equation? 9 plus 1 is 10. 10 divided by negative 2 is negative 5. 10 divided by negative 2, that's negative 5. Isn't it still true? Yep, still true. Even after we've divided by the same negative number on both sides of the equal sign, okay? So this is all dealing with equations, and so does this little summary down here. I want you to write this down. When you have an equation, again, it's an equation. This front page is about equations. And you add, subtract, multiply, or divide by the same number on both sides of the equal sign, The equation will remain. Think about it. And if you're not sure, reread maybe that top part up here to help you out. Okay, please go ahead and turn over the paper where we're gonna talk about inequalities, okay? So, unlike equations, inequalities do a weird thing when you multiply or divide by a negative. So it's inequalities. And they do a weird thing when you multiply or divide by a negative number. Okay, and I'm going to show you what the heck happens. So we've talked about when you multiply or divide by a negative, you need to reverse the sign at the very end. You know, you need to flip the inequality sign at the very, very end, only if you multiply or divide by a negative. Here's why, okay? We're going to have numbers that show you why you have to do that, okay? All right, so let's see what happens when you, let's see, these are all inequalities. So let's make sure it's true. So 4 plus 1 is 5. Is 5 less than 10? Yep. So yeah, that's true. All right, so what we're going to do now is we're going to add the same number on both sides of the inequality sign. So let's go ahead and add, let's add 3. So 5 plus 3 is 8. 10 plus 3 is 13. Hey, is that still true? Is 8 still, is this the left side less than the right side? Yep, so that's still true. So you should know that when you add by the same number both sides of the equal sign, you're just gonna keep the same exact symbol. Don't do anything psycho, okay? All right, let's now do this one. Subtract the same number on both sides of the equal sign. So just subtracting. Let's first make sure this is true. 7 plus 5 is, that's 12. And then 11. Is 12 bigger than 11? Yeah, that's true. Okay, let's subtract the same number on both sides. So let's just go ahead and subtract 3 this time around. Okay, 12 subtract 3 is 9. 11 subtract 3 is 8. Is the left side still bigger than the right side? Yeah. So yeah, that's still true. So nothing special happens when you subtract by the same number on both sides of the equal sign, of the inequality sign. So don't do anything weird when you're doing that, when you're solving inequalities, okay? All right, now we're going to multiply by the same positive number on both sides of the equal sign. So multiplying by a positive, let's make sure this is true. So that's 3, and then 2 plus 2 is 4. Is the left side still smaller than the right side? Yep, so that's true. Okay, so multiply by the same positive number. Let's multiply by 3 times 3. 3 times 3 is 9. 4 times 3 is 12. Is the left side still smaller than the right side, like the inequality indicates? Yep, still true. So don't do anything weird when you multiply by the same positive number to solve an inequality on both sides. Okay, still true. Okay. Multiplying by the same negative number on both sides of the equal sign. So remember, I kind of already flagged this. When you multiply or divide by a negative, so we know something's going on right here. Okay, so let's go ahead and check this out right here. Yeah, 6, and then 3 plus 1 is 4. Yep, okay, so that's true. So you're going to multiply by the same negative number on both sides. Multiply by the same negative number. Let's multiply by negative 3 times negative 3 times negative 3. So negative 3 times 6 is negative 18. 4 times negative 3 is negative 12. Now, is the left side still bigger than the right side? No, 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 it's not. This is where you need to reverse the sign. See what happened here? So when you are solving an inequality, with variables, and you multiply both sides by the same negative number, the very end, you got to flip the sign to make sure to keep it a true statement, because this right here, this is false. Oh, wait, no, hold on. I messed up here. So it was negative 18, negative 12. That is false. Okay, we had to flip the sign to make it true. Okay, so see how when you went negative 3 times 6 and got negative 18, and we went 4 times negative 3 and got negative 12, how we were like, oh, let's keep the sign because that's what we normally do. But look, this is not true. Negative 18 is not bigger than negative 12 because negative 12 is further to the right on the number line. So therefore, we had to flip that sign to make this a true statement, okay? So whenever you multiply by the same negative number on both sides of an inequality sign, you better flip the sign at the end. So reverse it. That is super important that you know that, okay? When you do any of these other things up here, you're still cool. Just keep it all consistent. But boom, when you multiply by the same negative number on both sides of that inequality sign, at the very end, you better flip it and memorize that. You have to know that. It's part of the 7th grade standards. Okay, let's see what happens when you divide by the same positive number on both sides of the equal sign. So let's see, 5 plus 3 is 8, and that's 10. So yeah, that's true. Okay, we're going to divide by the same positive number. So let's divide by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Is the left side still smaller than the right side? Yeah, so that's still true. So when you divide by the same positive number on both sides, you just keep it consistent. Okay, dividing by the same negative number on both sides of the equal sign. So again, when you multiply or divide by a negative, something weird happens. So that's a red flag right here. I'm going to circle it because you need to make sure that you are aware when you examine this problem. Okay, so 10 plus 2 is 12. Yeah, that's bigger than 9, so that's true. Okay, so now we're going to divide by the same negative number on both sides. So we're going to divide by, let's divide by negative 2. Divide by negative 2, divide by negative 2. So 12 divided by negative 2 is negative 6. 9 divided by negative 2 is a negative 4 and 5 tenths. So let's see, follow the sign. Is that true? Is negative 6 bigger than negative 4 1/2? No way, that's false. So what we have to do is at the very end, we had to reverse the sign to make it a true statement, okay? So had to flip, or you could say reverse, the inequality sign to make it true. Okay, so that's important. Flip the inequality sign. Sorry, I am being so sloppy. Okay, so only in these two instances, when you're solving an inequality and you multiply or divide by the same negative, you flip it at the end. When you're dividing by the same negative, you flip it at the end. All other cases, you're cool, keep it consistent, okay? So I want you to finish this statement, write it all out, yes. When you blank or blank by a blank number, you must flip or reverse the inequality sign at the end. So when do you have to flip or reverse an inequality sign at the end when you're solving an inequality? What are the situations? What are the circumstances? Bye.